Greetings of the day. Myself, Dr. Imran Kuttagola, Assistant Professor in Department of Civil Engineering, MITS deemed to be University. So, last modules we have seen some concepts on smart construction, BIM, and artificial intelligence in modern civil engineering. So, today we'll continue the same topic and we'll see the user interface of Revit architecture and we'll discuss some AI tools used along with BIM in smart construction. So, just we have a recap here. So, we have seen the BIM introduction part in detail and the BIM process life cycle, everything we have discussed, and BIM software tools, different tools we are using in the current industry we have seen, and we have seen the user interface of Revit architecture, where you can see here the same reference I have kept for your understanding. So today we are going to discuss some Revit demonstration of all the components and development of walkthroughs and renderings of components or structure. Then we'll go through the how AI transforms construction and we'll see the future of civil engineering. Yes, walls. So in walls, in Revit architecture, walls is a smart intelligent system where we can draw directly by using the walls component available in the menu bar. You can see here the sample of walls. I have extracted this from again the Revit architecture interface, where the walls can be drawn of any dimensions. Just draw the walls in the plan section. If you go through 3D, the height, elevation, everything we can mention in the properties panel. Then we can get the 3D modeling of this wall directly. So this is a smart intelligent system where we can adjust and modify the dimensions of these walls. Even the properties of the walls we can adjust from the properties menu. We can go and click on the different types of bricks available, concrete panels available, everything we can modify, and we can duplicate the wall properties and we can create our own wall. Here we can see the wall structure, where how the core boundaries structure. We can modify here the core boundary. We can give a insulation layer here. If not required, we can adjust the external and internal plastering thicknesses. Everything we can modify in the properties. Then come to modifying tools. We have different modifying tools similar to AutoCAD here. We can make the mirror of the components here. We can trim the components. We can move the components. We can create an offset. Very similar commands as of AutoCAD. So before starting of the project, we can create levels and grids here. We can see here 3 levels are available: ground floor, first floor, and roof. So for any project in Revit architecture, we have to create levels and then we have to make a grid for positioning of the columns. So we can have some intelligent component system available in the Revit architecture. We can see here the doors we can download from the families. We can have a library in your Revit architecture. Different types of doors, different types of windows, different types of furniture, everything we can download from the Revit architecture family components. Our families are components we can directly install wherever required in the structure. And we can see here a door can be installed directly clicking on the door from the menu bar. So directly pick the door type of door required. We can edit the properties of the door, sill height, everything we can edit, and just place the location on the wall. See, if you can't place other than a wall, a door component, we have to place exactly on the wall. Just show the location like I have seen here. I have shown here the location of the door is placed. Even the swing, everything we can edit the after placing a door. So the generally we can place a door and we can adjust the location precisely after placing the door also. Similarly, windows can be placed and any other components we can place in a structure which can be taken from the families. Even we can load families, different lower types of families we can download from the Autodesk website. Yes, then after completing the structure, floors and roofs can be directly placed on the wall sections. So this is the easiest part in the Revit architecture. A floor or roof, we have to develop a plan. After going to the plan, we have to pick the walls or pick the reference lines. We have to draw a rectangle. Directly we can draw a rectangle if it is a simple rectangular structure, and we can create a floor or roof in easiest way in Revit architecture. Yes, we can also give a floors. We can give a marble or granite or any floor component we can download from the families we can assign. So here you can see a roof structure where lightings, everything we can give as a component in Revit architecture, and if we render we can see the magic of this creation. Yes, staircase, very wonderful component in Revit architecture. In AutoCAD, we have to draw the staircase, each and every step, thread, everything we have to given. But here, automatically intelligent staircase systems are available in Revit architecture, where we can directly pick the type of the staircase required. If not, if it is not suitable for your project, you can draw the staircase and we can see a 3D view of the staircase. Just directly move the staircase and place in the required location, like as I have shown in these pictures. All these pictures have been taken from Revit architecture user interface only. Yes, after creating all the components, even we can do a sun path study where we can study the direction of the sun, we can study the traveling position of the sun and how the shadows has to be, and everything. If we see a rendered images, we can see here the shadows of the structural components, how it is. If we do a sunpath study, we can we can define these shadows. We can take the rendered images in evening, night views, or even afternoon or day views. We can do only if we do the sunpath study. That we can do very easily, comfortably in Revit architecture. Yes, rendering. So after completing all the structural components, we can render our structural views. We can do the camera position, like this left image. We can see a camera is positioned at some corner of a building. We want to see that view, particular view. We have to adjust the height of the camera. Everything we can do. Then we can see the right side image, how the camera has taken the rendered image. We can render with realistic views. We can see the lighting, we can even adjust. You can observe the background of this image, rendered image. We can adjust the natural lightings, everything, and even interior also. We can see there are panels, lights available interior. If you select the timing of this rendered image, even you can see the interior lightings also. Yes, we can develop a walkthrough. A beautiful walkthrough can be developed. For your reference, I will show you a quick walkthrough here. We can see the walkthrough is playing here. See, we can roam around the building. We can move our camera positions. Just we have to do is we have to position the cameras and align the cameras. We have to in whichever way we want. We see this building is completely surrounding by cameras, and it is capturing the complete video of this building from external. Even we can do from internal also. We can walk from external to internal and it will generate a beautiful walkthrough. Even if you see after rendering this walkthrough, you can see the purest quality of this walkthrough, because it will take, yes, it will consume lot of time if you want a realistic walkthrough. And if you have high equipped laptops or systems, you can generate these walkthroughs beautifully. Yes. So this is about the Revit architecture user interface. Just have gone through a glance of some of the important components how we can develop in Revit architecture. Yes, now we'll talk about AI. How AI has been transforming this civil engineering construction. How AI is assisting BIM to develop these smart constructions. So we'll see AI is nothing but artificial intelligence. It is transforming the construction industry by improving designs, plans, safety, monitoring, decision making, complete maintenance of the structure. In each and every stage of the life cycle of a structure, AI will assist so that we can manage all this comfortably. It will works together with BIM, with data analytics and some automation tools to make construction projects smarter and more efficient. We'll see different AI tools were available. So in each and every phase, we can make use of this AI so that we can develop the eco-efficient structures. We'll see in design and planning stage how AI is helping engineers and architects to generate the optimized designs, and we can detect errors before construction begins. So we will optimize. In last module, we have discussed how the AI is how the BIM is helping in optimizing the designs. So if we make use of this AI also, but there are many AI tools required available in the industry for optimizing this design, so that we can select a best optimized design out of thousands of the designs available. So what are the different applications of this AI in design and planning? We'll say automated design generation. We can automatically, the designs will be generated which are again optimized. So we can detect the clashes and we can resolve these clashes in the BIM models. We can optimize the designs. We can analyze the structure. Structure analysis can be done automatically by using these AI tools. So there are different AI tools available for designing and planning stage. So one of these which we have seen in detail till now, Autodesk Revit. So and there are some other tools available: Autodesk Generative Design, Navisworks to detect the clashes in the structures, and Tekla structures, especially for steel structural building modelings. So these tools will optimize in design and planning phase. So we can see in AI in construction project management also, which is a crucial part of the structural development. So this AI analysis the project data to improve the project schedule, planning, cost estimation, and risk prediction and delay analysis even. So we can predict by using AI tools, we can predict all this and we can estimate the exact cost also. We can analyze the risk and we can eliminate the delays. So what are different applications? It will predict the project delays and it will estimate the cost and it will give the complete budget of the project even before construction, and we can allocate the resources for labor or material, whatever we can allocate the resources. If there are deficiency in the resources, we are lagging in the schedule, we can align along with the schedule and we can allot more resources if required, and even we can track the progress of the construction. So there are different AI tools helpful for this construction project management, for which is major part is Autodesk Construction Cloud, and even there is Procore, and especially for project planning scheduling we'll use Oracle based Primavera P6 software, and one more there is an MSP Microsoft project also, and allies technologies. There are many AI tools which will be helpful for this construction project management. Even for construction site monitoring, let's see if we are doing a construction site, there is a huge number of blocks being constructed simultaneously. A site engineer, a supervisor can't go here and there in each and every corner of the building, but by using AI tools he can monitor the construction site without even going to the remote locations. So this will combine with the computer vision and drones. It will make use of the help of the drones to monitor the construction site. So here we'll capture the images from the drones and it will be fed to the AI tools. They will detect the how whether the work is going smoothly or not. We can monitor the site surroundings. So what different applications are, we can progress the tracking using site images. The site images will be captured by using of drones, and these images will be analyzed by using AI algorithms. So safety monitoring can be done. We can detect the unsafe worker behavior. If a worker is not doing a proper safety, dog not doing by following these safety precautions, we can detect easily, and even we can inspect the quality. So different tools available are AI tools, Open Space, Buildots, and DJI. Especially for safety management also, we can detect the by using AI tools in real time constructions, we can prevent the accidents and we can improve the worker safety. So PPE detection we can do, personal protective equipment, whether he is wearing or not properly, we can detect by using these AI tools. AI image will capture and it will analyze whether that person or is following proper guidelines or not, whether he is wearing all the PPE equipment kit or not. We can detect by using by not visiting the site also, we can detect by using AI tools. We can predict the hazards. We can safety compliance monitoring can be done in remote from the remote locations by using these AI tools. Different tools available for this safety management are smartwid.io and everguard.ai. Yes, AI is helping in quantity takeoffs and cost estimation also, as we have earlier discussed. Even directly from drawings and BIM models, we can develop the cost estimation. For this, some AI tools will assist our Costex and PlanSwift. Yes, AI is there is an another technology known as digital twin technology. if we combine AI with this digital twin, even we can generate better smart constructions. Digital twin is nothing but a similar model of your prototype or model of the real-time structure. We can generate a BIM, like an example we can call as a BIM. We can develop a model, so we can create a twin model. Twin is nothing but a similar to the existing one. The any changes to be done in the main structure, before that we can do a changes in this digital twin. Then we can see the changes, we can see the clashes, everything, and we can reflect the same in the real-time structure. So this integrates with digital twins to simulate and monitor the infrastructure throughout its life cycle. Even after construction, if we want to do say some any reconstruction work, first we will work out on the digital twin. Once everything is ready, we can say execute the same on the real-time structure. So real-time infrastructure monitoring can be done. Smart city planning can be done by using this technology, and life cycle management throughout its life cycle. We can manage the buildings and bridges. There is a digital twin technology AI. We can use these AI tools: Bentley iTwin and Autodesk Tandem. Yes, this is the future of civil engineering. Civil engineering is not like we can't say this is updating like anything. AI tools are being implemented in civil engineering also. The future of civil engineering is, please remember, BIM, AI, and digital twin. If we club all this, we can develop the smart infrastructures. If you have any queries, you can drop in this feedback form. So thank you so much.